Am I audible?
Yes, sir.
Okay. Yeah, so we'll wait for 2, 3 more minutes so others will join, and then after we'll start today's session.
Okay, sir.
So, yeah, so hello everyone. So, meanwhile, we are waiting for other people to join this session. If you have any questions regarding any of the topic which we have covered till now, you may ask. So, meanwhile, others are joining. Can you anyone tell me how did you find this course till now as we are closing in this class, this course? So, how was your experience regarding have you learned anything new or have it improvised what you have already known?
Gained a lot of practical knowledge, sir.
Okay, so hope that you will use the same thing in your project assignments or in your work.
Uh, like
Yes.
using of GS tools.
Yes.
Hi everyone, good evening.
Hi.
So my experience over this GIS was quite, a roller coaster journey because being from a CS background, exposed to such a civil course was, initially challenging, but then over the time it was quite okay. And yeah, thank you so much for this course. So yeah, hopefully I can clear all my doubts in this session. And
Yeah, sure.
yeah, hopefully I'll perform well. Yeah.
Yeah, that's the
Because
plan.
the upcoming exam is like really important for the certification even in the
Yes,
college as
exactly.
well, so yeah,
Exactly.
we'll,
So I recommend
yeah.
everyone to go through the questions which we have prepared in the last 12 week. So these links are already available. So you can just go to each week and try to give us try to solve all those questions which are shared in the Microsoft form. So that will give you a good practice before your exams.
Yeah, just curious, so we are asking, will the exam be really tough or is it
No,
going
no,
to
no,
be
no. It will
manageable?
be same level as you are expecting in your assignment. So
Oh,
it will be same level.
okay, thank you.
And yeah, and some of the tough questions, if they have, then we'll solve that same question here today because today we are going to solve some of the questions from which are asked in GATE examination from this GIS uh, part in the geomatics engineering paper. So I have covered like last 5 years of question when this subject has been introduced. So since then it was offered for 5 times in the last 5 years. So in that question paper, whatever questions has been asked, so that will go in a solve today. So that will give you the overall idea about what kind of difficulty you can expect at maximum level in exams like GATE as well. So for this NPTEL exam, it's like the assignment level questions and the questions which we solved in this doubt solving sessions are enough. You can just go through all the week contents and so try to solve, because each week has around 40-50 questions MCQs, so you will have around like more than like 500 questions with you. So I think if you just prepare that along with your assignment, then also you will able to pass it very easily. Okay. So yeah, I think lots of people are here now. So we will start today's session without much delay. Before that, I want to ask, like, if you have any questions from any of the week contents, please let me know so that we can solve those doubts today as only. Okay, so yeah, let's get started. Yeah, so I think the screen is visible to you. Yeah. So the first question, which is here. So the question is like, it's like accuracy and precision. So two surveyors have done some analysis and they have got some result. So surveyor P, which like actual reading was around 20, like value is 20, but they got surveyor P, they got answers like 19.97, 20.02, 20.04, 19.98, 19.96, and 20.03. And another one got a results like 20.05, 20.07, 05, 06, 07, and 07. So now we have already discussed the concepts of accuracy and precision. So based on that, can you tell me like which of the following option is correct? The first option is observed values of surveyor P are less precise and observed values of surveyor Q are more accurate. P is more precise and Q is less accurate. P is more accurate and Q is more precise. P is less accurate and Q is less precise. So anybody wants to go ahead with the answer? You can take a time, think.
Option C.
Yes. So can you elaborate a little bit like why C option?
As you mentioned, that the correct answer is 20. So if you see towards the surveyor P, the value is quite close to 20, like 19.97 and 20.02.
Yes, exactly.
And it's very close. But if you see the Q, it's not close, but it's more precise. There are values which are getting repeated,
Exactly.
like that.
Exactly. Yeah. So that's the thing. So when we are seeing the accuracy, then we see how close the observation and the values which we have obtained. So what we do, we find out the error and take the mean error. So if we do that for the first option, surveyor P, then accuracy is basically the concept how close your measurements are to the true values. So here true value is 20 meter. And precision is how close your measurements are with respect to each other. So basically whether it's be consistent or repeatable or not. So here if we talk about first surveyor P, then if we take a mean of all the values, then it is a 120 divided by 6, which is equal to 20. So overall reading is 20 and the actual answer is also 20. So it's mostly more accurate one. P is more accurate. So option number A and option number B are automatically not correct because they are saying P is less precise and more precise. So I think we can remove that because P is more accurate. So based on C also you can give your answer. But yeah, to check the precision also, we'll see precision is means like the spread between the minimum and maximum values. So if we see for P, like actual value is 20 only, which is exactly true value. So we can say it's more accurate. But when we see the precision of P, then the difference between the minimum and maximum value is 0.08 meter, which is quite high. And because of that, it is less precise. So from this, we can say option A and option C both are correct. But to select one out of it, we have to go with the Q as well. So now for Q, if we do the like mean of all the values, then we can find out the error is around 0.062, which means that Q is less accurate. Okay. And in the similar way, if we see the minimum and maximum value of Q, then it is a very less, around 0.02. And based on that, we can say here that Q is more precise and that values are more consistent and reliable. So based on that, we can say that Q is more precise here. So Q is more precise. Okay, so option number C is correct. Any doubt? Okay, so these questions are might be a bit uh, tough. So if you have any doubt in between, please unmute yourself and ask. Now the next question is the zone number of universal transverse Mercator projection having a longitude of 67 degree, 20 minutes and 30 second is filling the blank. So here answer is given, but yeah, the way to calculate this answer is like, first of all, we have to recall what is UTM. So if you consider the UTM coordinate system, which we have learned in the various map coordinate systems, so it is a projected coordinate system in which our units are in meter. Another thing is that this UTM system is divided into 60 zones, and then it's like either in north direction, in south direction, and in from east to west, it is divided into 60 zones. So if we consider the longitudes, then they are minus 180 to 180, or we can say 0 to 360. So if we divide 0 to 360 into 60 zones, then each part will be equivalent of 6 degree wide. Now we will start counting from the back side, like minus 180 plus 6 and plus 6 plus 6 plus 6, like that we will try to add on. Okay, so on the west side you will see, so we will do what we will do, that whatever the longitude which we got, first of all, like it is in east side, so generally we'll start doing it from west. So 180 plus whatever the difference which we are having here. Okay, so basically what we are doing here is let me show you in the, so basically here we are having a line like this, which is from minus 180 to plus 180. So minus 180, 0 and 180. One side is east, one side is west. Okay, now this total is 360, and if we do this 360 by this UTM system is divided into 60 different zones. So then we'll do 60. Then we'll see that each block is of 6 degree. Okay. So now we'll see, try to doing this. This is the first 6 degree, like 180 minus 6 if you will, like plus 6 if you will basically add, then you will get 174. Then again you will add 6, 6, 6, like this you will add. Okay, and you will get each block. Now what you are getting here is, our question is asking us 67 degree, 20 minutes, 30 seconds. So now if we see from here also, then 0 to 6, 6 to 12. So basically this side we will have 30 zones, this side 30 zones, and this will start from west and this will go towards east. So obviously, first of all, our answer should be greater than 30. Why? Because here till this point we will have 30 zones, because this is 180 divided by 60. So we'll get around 30 zones this side, 30 zone on distant sides. So till this point we will have 30 point, then this is the 31, 32, like that. And what we have here is, that is between 67, 20 degree, 30 minutes. So first of all, we'll convert this from degree, minute, second to some values. So to do that, we have, let's say 67 degree, 20 minutes, and 30 seconds. Okay, so first of all, we'll convert this into decimal degree. So can anyone tell me how to convert this into decimal degree?
0.5089.
Exactly. But the thing to do is 67 plus, we will do 20 minutes. Okay, so we'll do 20 divided by 60. So that will convert from minute to degree, and then after we have 30. So 30 seconds. So second to degree. So that will be 60 into 60, which will equivalent to 3600. Okay, so from this we will convert into decimal degree, which will equivalent to around 67.3417. So 67.3417. So are you getting the same answer or not? Okay, now we got the 67.3417. So what we'll do is, this is in the eastern part. So we will add the another 180 to get from here to here. So that's why we are adding plus 180. Or else if you don't want to add 180, then you just calculate and then add 30. So we will add 180 into this. And then after we'll get that as a 240. 247.3417, and that we will divide it by 6. So whatever the answer we will get here, which is 247. So we'll take an integer of it, which is around 247, basically 3417. Then after we will divide it by 6, and then we'll take a integer of it. So basically we'll remove the floating points. Okay, so and then we will add 1, because whatever we will do, that plus 1, because it will add, like we do the calendar date, a minus b if we do, and we'll add 1. Okay, so that we will add. So your answer will become, this will come 41, and then we will add 1 into that. So that will give you the 42. So basically what is happening here is, let's say if you are doing it, then if you got the answer as, let's say 5 by 6. So if you take an integer of it, it will come as a 0. So we cannot go as a 0. So we have to make it 1. So basically in that case, what we do is, we'll just add 1 into our value. So if you do this, then you will get around 1. This will become 0 and this will become 1. So similarly here, 41 plus 1, 42. So whenever you solve this kind of question, do not forget the adding 1 and all those things. Okay, any doubt in this question? Okay, okay, then the next question which we have is, okay, the question is, the combined correction for curvature of earth and refraction in leveling for a distance of 6 kilometer would be filling the blank meter. So you have to round off to the 2 decimal place and assume the radius of earth as a 6370 kilometer. So basically, first of all, we will learn why this kind of corrections are necessary. So first of all, let's say this is the surface of earth. Okay, now you have kept your instrument here, or this we have discussed when we are doing the view shed analysis. Okay, So what is there? Like observer is standing here, and now observer is seeing in the horizontal dimension. But as the Earth is like Earth is having curvature, this light will bend like this. It should bend like this because if you want to see parallel to it. But as the curvature of Earth is there, and we are seeing in just horizontal direction, so at given point, this much error will happen because of the curvature of Earth. And another thing is that so basically this error will be like we should see at this particular location, but we are seeing at this. So this like this error is like you always you have to uh, like deduct because of this like curvature, and then this error is quantified as like if you do the uh, computation, then the formulas for these errors are like around 0.0785 into d square, 0.0112 into d square. So that is for curvature, and this is for refraction. So curvature correction you have to do like negative because what will happen is when we'll see the point, we will see at this location only with respect to this. And that's why, but we have to see this much. So when we'll do the correction, we have to deduct this value. And that's why curvature correction is negative. Whereas refraction is like as the light will pass from this one medium to another medium, then it will try to bend. Okay, and because of that bending, like that is because happening because of the refraction. So according to the Snell's law and all. So that correction is always positive. So one is negative and one is positive. And most of the time what happens is this two tries to balance each other. But the combined is minus 0.0673 d square, where the d is in kilometer and your correction is in meter. So you can remember this formula to calculate the correction, combined correction, which is necessary in viewshed analysis. So here just put the thing in this formula that we have 6 kilometer. So 0.0673 d is around 6. So you do 6 into 6, which is 36. So you will get around 2.4228 meter. And the answer here is around between anything if between 2.4 to 2.5 is correct. And if you have considered the negative value, then minus answer is also acceptable. So minus or plus 2.4 to 2.5 is correct. Any question here? Anyone? Any question? Okay. If there is no question, we'll move forward to the next question. So you can consider these things. This can be asked like the curvature correction is always positive. Ground is uh, like that is negative. So you have to do it like make it positive. And the refraction correction. Okay, if this correction is positive, always positive, then this refraction correction partially cancel it. So combined effects lifts the object slightly. So it's all depends on the how you are considering the dimensions or the plus or minus. Okay, next question is the representative fraction RF of the graphical scale given below. So which is 1 to the power x, where x is in. So here you can see this is the graph which is given to us. Okay, now what you can see here from this scale is 0 centimeter is equal to 0 meter, 1 centimeter is equal to 100 meter. So you see if you measure 1 centimeter on map, it will become 100 meter on ground. So how to read this scale is like 100 meter on ground is represented by 1 centimeter on map. And when we represent this ratio in a map, then the ranging factor or representative factor, or you can say scale, is equal to the distance on map divided by distance on ground. So how much scaling we are doing. So here the distance on map is 1 centimeter, whereas distance on ground is 100 meter. Now to cancel it out, we have to make the units of both of it in a same unit. So we'll convert 1 centimeter into meter. Okay. Or you can say you can convert that 1000 meter into centimeter. So 1 centimeter divided by 100 meter, then you will convert both into centimeter. So that will become 1 divided by 10,000. And here what is being asked to us is geographical scale given below. You have to find, like, scale is 1 raised to x. So you have to find out the value of x. Okay, so the answer will be 10,000. You do not have to write the value of 1 by x, because in that case it will be around 0.00001. But be careful with what is being asked, whether it's asked 1 by x or x. According to that, you have to write your answer. Okay, so let's give a small exercise to you. So let's say we have this scale which is being shown here. So 5 centimeter on map is represented by 1000 meter. So for this, find out the x value of x. The scale is 1 by x. So what will be the value of x? So anyone?
20,000.
20,000. Okay. So how we'll do it? 5 divided by distance on map divided by distance on ground. Now this is 5 in centimeter and this is in meter. Okay, so either we'll convert this into meter or we'll convert this into centimeter. So if we convert this into centimeter, we'll add 2 more and we'll do 5, 2, and then there will be 4 zeros. So the answer will be 1 divided by 20,000. Okay. Okay. Next question is satellite image with 6-bit radiometric resolution has filling the blank gray levels. So this question is from the types of resolution which we have learned in this class when we learned about the images, various kind of resolution in the DMV. So basically the satellite has 4 resolutions: spatial resolution, temporal resolution, radiometric resolution, and then spectral resolution. So here what we are talking about is radiometric resolution. So 6-bit radiometric resolution has how many gray levels?
Option C, sir.
Yes, so it has formula of 2 to the power 6. So 2 to the power n bit. Basically the formula for this is 2 to the power n. So here you have n as a 6. So basically you will do 2 to the power 6. So basically if you do this, then you will get 64 as a answer. Okay. So can anyone tell me, like, what is the radiometric resolution that current satellite have? Like, what do you think? Like, how much resolution they may have? Like, free of cost satellite. Any idea?
256, sir.
256. Okay. 256
No,
divided
this
by.
for display, modern satellites have up to 32-bit gray levels.
Okay.
16-bit, 32-bit gray levels, but in display we can see up to 8-bit.
Okay. So we can see like around 256. But yeah, if we can take an example of like satellites. So the satellite generally has like around 16-bit resolution, radiometric resolution. The Landsat and Sentinel satellite, they have 16-bit resolution. Okay. So the idea is like if you do 2 to the power 16, then you can see how much gray levels we can see. Okay. So now like I will show you one thing. My screen is, yeah, it's same big properly. So I think let me show. radio metric resolution of Landsat 8 is one of the satellite launched by US. So you can see it has 12-bit radiometric resolution. Okay, so it can distinguish around 4096 potential grayscale level. Okay, so you can see this OLI band, operational land imager, it has 12-bit precision. Whereas if we see the this data when they do the post processing, then they convert into 16 bits scaling. So whatever data which we get from us, it has differentiation of 0 to 65,535 colors. Similarly, if we see another popular satellite, which is Sentinel-2, then it also has a radiometric resolution of 12-bit and 13 spectral band. So basically, roughly they have 12 to 16 radiometric resolution. Okay, I think that is clear to you. Now, moving to the next question. So thermal infrared images are provided by which of the satellites? So this thermal remote sensing part we have discussed when we discussed about the elevation reconstruction from DEM. That we have discussed that both are inversely proportional. That height of DEM is inversely proportional with the temperature. So that time we have discussed about this thermal infrared images. So which of the
Option D.
D? Yes. So option D is right. So here we get just explanation for that. So thermal infrared is like in the range of 8 to 14 micrometer wavelength. Landsat TM has thermal infrared channel, whereas this first one, Landsat MSS, is there. It has just visible band only, which is in multispectral, not any band related to the thermal. Okay, then this NOAA it also has thermal infrared. Then we see sports and cartosats. So they are very high resolution satellites. Satellite like high resolution means they do a mapping at like less than 1 meter. And because of that, what happens like this sport basically, what happens that they do not get sufficient energy for the thermal sensing the thermal data. And because of that, it does not have any thermal band associated with that. And similarly, this Econos and Quick Bird, they are also very high spatial resolution, means the size of spatial resolution is very high, but they do not have any thermal band associated with them. And the reason that they do not have is that amount of pixel is very small, and amount of energy that will be emitted from the pixel is very less, that cannot reach to the satellite, and that's why this high spatial resolution satellite do not have any thermal band associated with them. Okay, so the next question is, now let's say you have two images, the spatial which is the spatial resolution of a satellite image P, or you can see we have 2D. Okay, the one DMP is having 80-meter resolution and another DMQ is having 20-meter resolution. Now both have 512 by 512 pixels. So number of pixels are same in both images. So which of the following will be correct here? Image P will cover 4 times the area of image Q. Image P will cover 16 times of the area of image Q. Minor detail will be more clear in image Q as compared to image P. And image P is higher resolution and image Q is lower resolution.
Option B, sir.
Okay. Option B. The P will cover 16 times.
Option C.
Okay. Option number C. So B and C. Anyone else? We got two response, B and C. So let's decode this. So first thing is that both image have same pixels. Okay. which are around 512, 512. So I have this image and this image. Okay, both has 512 pixels, 512 pixels. Is it clear? Now, so pixels will be like this. So the size for the image 1 is 80 meter by 80 meter. Now, for the same case, if I take the second image, then for second image, this pixel size is around 20 meter. Okay, so this is 80 meter for image P, and this is 20 meter for image Q. Now, if I want to calculate the area of both these images, what should I do? This is the square image because I have 512 pixels in a height and 512 pixels like this X and Y dimension. So, okay, so this is square only. So the area of this will be L square. Okay, now how to find the length of this square? So we have pixel size 80. So we'll do 80 into 512. Similarly here for this image, we'll do 20 into 512. Okay, so 512, 512 will be similar in both. So if I want to compare the area of P divided by Q, then 512 into 80 into 512 into 80. So here 512 will be cancel out. So what I will have here in P is 80 by 80. And here on Q, what I will have as a 20 by 20. Okay. So you can see if you do this, then you can see this will go 4. Similarly here also we will get 4. So what is the answer? 16. So what you can see is area of P is 16 times higher than area of Q. Okay, P is equal to 16Q. And that is obvious because both has same number of pixels. But in P, the pixel size is bigger. So it will cover more area. So that is obvious that P will have more area. But how much? So 16 times more area than Q. And another thing is that here the 1 pixel is 20 by 20 meter. Here 1 pixel is 80 by 80 meter. So if I want to see small buildings, small houses, then which one, like in which image it will be clear? So in image in which the spatial resolution is high. So spatial resolution high is in Q. So you can see more detail in image number Q, whereas you can see less detail in image number P because the spatial resolution is very coarse. So option B is right, and minor details will be more clear in image Q as compared to image P. That is also correct. Image P will cover 4 times the area of image Q. That is wrong. Generally what people do is they do it by just 1. So that's why 20, 80 divided by 20. So they will get 4. And that's why they have given this option to make you confuse. Similarly here, if we see the option number D, that image P is high resolution and image Q is low resolution. So that is also wrong because in image number Q, the pixel size is 20 by 20 meter, which is higher spatial resolution. And that's why it is a high resolution image rather than low resolution. So Q is low resolution and Q is high resolution and P is low resolution. Any doubt? Anyone? Any doubt? So both option B and C both are correct. I'm telling you again, this question has some bit difficulty level compared to what we have solved. So if you have any doubt at any point of time, please unmute yourself. If you do not get any one part also, please unmute and ask. Okay, so the next question is the number of bytes required to store 8-bit uncompressed images of size 512 by 512 pixel is how many? Okay, so first, because before going to forward, you should understand the concepts of beat, byte, and all. So I think, can anyone tell me like how many beat is equal to 1 byte?
8 bits equal to 1 bytes.
Yes. So we have 8 bit, because these questions are very like similar in most of the exams. 8 bit is equal to 1 byte. Okay, then when you say byte and kilobyte, then how it will change? Like how many bytes is equal to 1 kilobyte? So you see your files in KB, which is kilobyte. So how many bytes is equal to 1 kilobyte?
1024, sir.
Exactly. So generally you will see 1024, but if we refer the word like kilo, then it is like divided by 1000. So sometimes if you do not get any answer, you should do that as well, because sometimes answer is based on that. But mostly we will take this. Okay. Similarly, then we'll see like kilobyte to megabyte, or you can say MB. So how many kilobyte is equivalent to 1 MB? Again, same 1024 KB is equal to 1 MB. Okay, so we'll keep this relationship in mind. Now we'll see our question. The number of bytes required to store an 8-bit uncompressed image of size 512 by 512 pixel. Now how many pixels we have? 512 by 512. So we'll see how many space we need for 1 pixel, and then we'll multiply it by 512 by 512. Now how many like storage is have, like 1 pixel is having 8 bit. Okay, so now 8 bit into 502 into 502. So we'll get total number of bits, which is around 20,97,152. Now to convert that from bit to byte, because they have asked us to give the answer in bytes. So that's why we have to divide it by 8 to convert that from bits to bytes. And then we will get this answer is 264 into 264, like 2,62,144 bytes. And if they ask you the answer in a kilobyte, then you divide it further by 1024. So you will get around 256 KBs. And then again, if they ask you the answer in MB, then it will become 0.25 MB. Is that correct? Like, is it, like, do you get it, what I'm saying? Okay. So now let's move to the next question. So this question is also again the same question, but bit complex. To store a 3-band, 4-bit, 512 by 512 size image without a header, the number of storage bit required is bits. They've asked question in bits. But in the earlier question, we had just one image. Now here it has 3 bands. So can anyone tell me the answer here?
Option A.
Option number A. Everyone is getting same. Yes. Okay. So yeah, the correct answer is option number A. We just have to multiply 3 again. 3 into 512 into 512 into 4-bit. Okay, so 3 band. Each band has 512 by 512 pixel, and then 1 pixel has 4 bits. Okay. Now next question is the minimum number of 2-dimensional ground control points required for second order polynomial mapping for image georeferencing is how many?
6.
Yeah, so can anyone tell me the formula which we had for this?
P plus 1 into P plus 2 by 2.
Yes, p plus 1 into p plus 2 divided by 2. So we will apply this formula and we put the two-dimensional polynomial. So here 2 plus 1 3, 2 plus 2 4. So 4 into 3 12 by 2. So answer will be 6. Similarly, if you have three-dimensional polynomial, then it will become 10 GCPs. Okay. And I think there was a thumb rule also, if you have remembered, that if you have this many GCPs, so better to take 3 times of points than what you have got from this value to get the more accuracy or more robust georeferencing. Next question is, in a spatial interpolation using coordinate transformation for image to map rectification, the minimum number of ground control points required to perform a third order transformation is 10. Using the same formula, you will put 3. So 3 plus 1, 4. 3 plus 2, 5. So 5 into 4, 20 divided by 2. So you will get answer as a 10. Now next question is, the pixel value for a 3-band 8-bit image are 127, 127, 127. On an RGB color display, the pixel will appear green, black, gray or white.
Option D, sir.
Option D. So D, like when you say white color, what is suggested by white? Like when we say it's a white color.
It will be gray.
Yeah. Okay. So this is the value is in RGB. Okay. So now RGB, like when we have all color 255, 255, 255, then it is classified as a white. If it is all 000, then like for black, it is always 000. So for black, we'll have 000. For white, we have 255, 255, 255. Okay. And then for green, we have this is RGB. So R will be 0, G will be 255, and B will be 0. So that will represent green. Similarly for R, 255, 00, and RGB. So for blue, 00, 255. And if all the values are similar, then it is a shade of gray. Okay. Now, next one. Okay. So the brightness value of 4 pixels in an input image are shown in the table below. The image is rectified using nearest neighbor intensity interpolation. The pixel at location 5, 4 in the output image is to be filled with the value of the coordinate 5.3, 3.7 in the input image. The brightness value of the pixel located at 5, 4 in the rectified image is filling the blank. Here it's a 5.3, 3.7. So location of pixels in input image. So input image and then the brightness value is given. Now the image is rectified using the nearest neighbor intensity interpolation, and the pixel located at 5, 4 in the output image to be filled with the value of coordinates from 5.3, 3.7 in the input image. So when you do this transformation, let me show you how this happens. So this is the normal image. Okay, so this is the original image. Okay, and in this, let's say these pixels are like this, 0, 0. Okay, then this will be 1, 0, 2, 0, 3, 0. Then this will be 1, 1, 2, 2, 3, 3, 4, 4. So what they are asking is one pixel. Let's say that pixel is 5 by 4. Okay, so let's say 1, 2, 3, 4, 5. 1, 2, 3, 4. So this pixel we are talking about. So this pixel is 5, 4. Now this pixel, if we see in the rectified image, so this black one is a rectified image. In this pixel 5 by 4 is coming over here. Okay, over here. So in input image, that pixel is at what location? So you can see here, this is 5, this is 4. Okay, so 4 point something and 4 point something. Okay, so 4 point, let's say 2 or 4.4, this pixel is at. So what you have to find when this will be transformed at this location, what will be the value here? Okay, so that you have to see. Now what you can see here, this pixel, which we are correcting, that is nearest to which pixel? And based on that only we will see, because we are using the nearest neighbor. So we have to find out nearest pixel from this value, 5.3, 3, 3.7. Okay, so if I do this, the nearest neighbor operation finds the closest pixel to the source coordinate. Okay, now this is your coordinate and you have to find which coordinate is closest to this one. So 5.3, 3.7 is closest to which point? So 5.3, so that is more near to 5, and 3.7 is more near to 4. So the correct answer will be 5, 4, which will be 11, because nearest neighbor will take the nearest point and we will assign the value of it. Similarly, example, if I see here, because like this transformation is not same as what is being asked in question, but what I'm saying is, now if you want to rectify this point, if you want to get the data of this point, or basically this point, so basically this center data you want to achieve wherever the centers are there. Okay, so what you have to do is, let's say if you want to fill the data of this center, you have to see which center is nearest to it. So for this particular, now if I'm finding this one, so these are the 4 input column which are near to each other. So I will see their coordinates and I will find the distance with respect to each point. And I will see which is the nearest to the given data point. Okay, so then if this is near, then the directly answer of this will come. This is near, then this will come. So according to this algorithm will work. Any doubt? Okay. So the next question is, like blank is the raster image sampling technique that does not alter the any of the output cell value from the input raster dataset. Nearest neighbor, cubic convolution, bilinear or kriging?
Option A, sir.
Nearest neighbor, because it's just we are putting the value of nearest point. We are not doing any interpolation kind of thing here. So that's why the correct answer is nearest neighbor. Next question is, this is also similar to the bilinear interpolation, which we have learned in the interpolation chapter. So in the grid below, the 4 corners A, B, C, D has pixel location on an image, and the brightness value at A, B, C, D are 10, 20, 5 and 30. Now you have to determine the value of P at 7, 4 using the, like you have to round off till 1 decimal place. So we have to find out the value here. And if you see the data given to us, then at 0, 10, like at A, the data is 10. At B, the data is 20. At C, think I will just do in PowerPoint. Then C, we have a data of 5. So here we have 5 and here we have 30. So we have to interpolate the value at this location. Okay, so we'll do that first in the x dimension and then in the y dimension. So if we do from in x dimension, so what is the value here is 5 and 30. Here 10 and 20. So if here the change is around 25, which is at 10. So if the distance is 10 meter, then the difference between these two values is around 25 meter or 25, not unit any. Now, how much distance is there? So if the distance is 7 unit, then what should be the answer? So what you will get here if you will do, can anyone tell me? So at this location,
17.
yeah, at this location you will get 17.5 using just normal linear interpolation, 17.5. Similarly, if you will do here, then the 10, 10, 7, how much? So 70 by 10. So you will get value as 7. 17. Okay. You have to add also. Here you got 17.5. So that is a like addition. So we have to add 5 also in that. 17.5 plus 5 because we are checking the difference between this point and this point. So here when we do that, you have to also add the initial value as well. So 17.5 plus 22.5 plus 5. So that will become the 22.5. Here also 10 and 20. So that is if you divide into 10 part, it will like addition of 1 unit. So 10 plus 7, it will be 17. Now we go 22.4 here and 17 here. So now we'll do the interpolation in this direction. So how much change is happening from 22.4 minus 17? So that is change of around 5.4. If you are going from this point to this point, it is decreasing by 5.4. And that is how much? 10. So if you are going 10 units in the y direction, it is decreasing by 22.4 minus 70, which is equal to 22.4 minus 17, which is around 5.4. So it is decreasing by 5.4. Okay. And then after, if this distance is 4 unit, then how much? So 5.4 into 4 divided by 10. So 2.16, it will decrease by 2.16. So 22.4 minus 2.16. So you will get around 20.24, which will around become around 20 point. Okay, 20.24. So around approximately you will get 24.3 as an answer. Any doubt in this question? Any doubt in this question? Okay, so now I will move to the next question. So the next question is a geometrically distorted image is corrected and the pixel values are assigned using resampling techniques as shown in the figure. Okay, so yeah, like the dotted one is our distorted image and that we are correcting using this black image. So after the correction, it will look like this. So in this context, which of the following option is or are correct? So the first option is bilinear interpolation technique assigns the output pixel value based on a distance weighted average of digital number using 2 by 2 nearest pixels, or you can say 4 nearest pixels. Cubic interpolation will do using 16 pixels, which is 4 cross 4 pixels. Bilinear interpolation technique assigns the output pixel value based on a distance weighted average of DN values using 3 cross 3 pixels, or cubic interpolation technique assigns the output using 3 cross 3 nearest pixels. So which of the following is correct here?
A and B, sir.
A and B. Yeah. So in bilinear, we'll use 4 pixels, and in cubic, we'll use 16 pixels. Again, the similar question. A 4-band multispectral image with pixel size of 50 meter by 50 meter covers a ground area of 20 kilometer by 20 kilometer. If the radiometric resolution of satellite data is 8-bit, then the uncompressed satellite image contains how many kilobytes? Now in the previous question, what was there? They have already given us the number of pixels. I say 512 by 512. Here they have not given us the how many number of pixels are there. But what they have given is one pixel size is 50 by 50 meter. And it is covering the area of 20 by 20 kilometers. So can anyone tell me that how many number of pixels will be there first of all? How many number of pixels will be there?
Uh, 1,60,000 pixels will be there.
Yeah, 1,60,000. Yeah, and if we want to see in terms of cross, then how we can see is like we have 20 kilometer by 20 kilometer. So total area is 20 kilometer, 20 kilometer by 20 kilometer, and one pixel size is 50 meter. So what we'll do is we'll divide that by area of one pixel. So 20 kilometer, which is like first we'll convert from kilometer to meter, then we'll divide it by 50. So this will go cancel out, and 5 4s are 400. Okay, so in one dimension we have 400 pixels, and another dimension we have 400 pixels. So your image will become 400 pixels divided by like multiplied by 400 pixels. So 400 into 400, which will become 160000. Okay, and then again what you will do, whatever you have done it earlier. So 40 into 40, that is the number of pixels. How many bands you are having? Similar bands. So we are having 4 bands. So this is the one band, second band, third band, and 4 band. Okay, so we are having this 4 bands. So we will multiply it by 4. And one pixel has how many bytes? One pixel has 8 bit. So we'll multiply that with 8. So if we do this, we'll get the answer in bit. And then after we'll convert that bit into kilobyte, and kilobyte into bit into byte, and byte into kilobyte. So can anyone tell me what is the answer here?
Six 25.
Yes. So here answer is 625 kb. But in the GATE answer key, they have given both the answers, 625 or 640. Because when we use the word kilobyte, then we'll just rather than we'll divide it by 1024, what we do is we just divide it by 1000, considering the kilobyte is like I said 1000 part. So in according to that, the answer is 640, and if we consider so like 1024 bytes, like is equal to 1 kilobyte, then the answer will be 625. Okay, so the next question is de-stripping in radiometric correction is used to correct a type of which kind of effect? So de-stripping we do to correct the sensor defect. These questions we have discussed while the class also, that this de-stripping is mostly affected because of sensor defect. Next question is number of cells required to cover an area of 9 square kilometer of ester GDM are. So first of all, this ester GDM. So you should know the size of 1 pixel in this image. So ester is having 30 meter spatial resolution. Okay, now you have to cover area of 9 square meter. Okay, and the 1 pixel area is 30 meter by 30 meter. So which will become around 900 square meter. And the total area which you have is 9 square kilometer. So you convert that area into meter square. Okay, basically you have 9 square kilometer. So you convert that square kilometer to 9 square meter. You do not have to multiply 9,9, okay, because already it's in 9 square kilometer. So you just multiply it with the 1000 to convert kilometer into meter. So you can like multiply it with the 10 to the power 6. And then after you divide it by 1 pixel area, which is 30 by 30. So you will get around 10,000 cells. Is it correct? Or are you getting it? Okay. If you do not get, please ask. Okay. In GIS database, which type of attribute may be used to represent area? Nominal, interval, ratio, ordinal.
Ratio.
Yes. So ratio is used to represent area. So nominal is a category data with no order, such as land use, forest, urban. It cannot be arithmetic. Then ordinal will be having some kind of order. That's a low, medium, high, moderate, medium, like that, with some kind of inferences. Interval is having 0 to 10, 0 to 20, so kind of intervals we can see. And ratio is ordered with equal intervals and true zero. It has true zero also. Interval do not have true zero, but ratio has true zero. So area, distance, population count, those variables can be represented by ratio. Now, what is attribute uncertainty? So in GIS, you have learned about the attributes. So what is the uncertainty of attribute? Error due to imprecision in coordinate registration, error due to incorrect labeling or quantification of features, error in source document due to cartographic bias, error associated with displacement of the objects from its true location.
Is it C?
No. So
Option D.
no. The
Yes,
correct
sir.
answer here is
Say
option
let
number
it B.
B. Why B? Because see, first of all, attribute is represents, like in GIS we have learned, like attribute means what? If you have a file of villages, then the name of village, how many people lives in village, what is a male, what is a female, those are the attributes. Okay, so now what is the problem that we might have done a mistake in doing the labeling? So when we create the data, while creating the data, we might have done some error. So that is the attribute error. It's simple. Whereas if you see the first option, it is coordinate registration. So that is related to some location. So that is known as a geometric uncertainty. Option number A and D. The fourth one is also related to the displacement of object from its true location. So both are related to the geometric, or you can say positional uncertainty, not the attribute. They are related with the location, not the data that location has. So we can directly remove the option number A and D from this. Now we remain with the option B and C. So cartography, again, it comes due to some kind of map projections. So it's a projection uncertainty, not the attribute uncertainty. error in the source document due to cartography bias. Cartography means how we are mapping it, not based on what kind of data it has. So option C is also cancelled because of that. So correct answer is B. So we have positional uncertainty and attribute uncertainty, temporal uncertainty, and cartographic bias. The next question is in GIS, blank triangulation is a proximal method that satisfies the requirement that circle drawn through the three nodes of a triangle contains no other node. Dalhousie, Delnully, David K. Davenport.
Option B.
Yeah, so it's Delnully triangle. So it's a very simple one. Next question is in GIS, reclassification is performed to group ranges of values into single value within a data layer, segments a data layer into multiple data layers, combines multiple data layers to a single data layer, classify a data layer using many attributes.
Option A.
Yeah, so what we do using reclassification is we group the range. And the classic example of this is we use during the aspect calculation. So aspect value, if we want to reclassify into north, northeast, east, then we'll classify it like if the value is between 0 to 45.5 degree, then it's a north, then 45.5 to 45 degree to around, let's say, 225 degree, then it is a east. So like that, it is a classification in 4 dim. Like we have earlier continuous data that we classified into 4 data. So it groups the ranges of value into a single value within a data layer. So option number A. Next question is centroid of a polygon is geometric center of polygon, arithmetic mean position of all its vertices in two coordinate direction, the point at which a cutout of a polygon could be perfectly balanced on the tip of a pin, and center of a polyline.
Option A.
Yeah, option A is right, but this is, you see other options as well, because this is a multiple choice question.
Option C is also correct, I think.
Yes, C is also correct. And option B is also correct, because when we calculate the mean, we'll take all x coordinate and we'll do the mean of it. We'll take all y coordinate and we'll do the mean of it. So we'll get the arithmetic mean of x and y. So option A, B, and C, all three are correct. Okay, so the area of a buffer of 50 meter around a proposed 1 kilometer straight road segment to restrict any future construction is, so basically we are constructing a buffer around a 1 kilometer straight road, and that buffer is for 50 meters. So what will be the area of that buffer? So basically this is a road of 1 kilometer and then we are constructing this kind of buffer. So buffer in, like you will see this. Okay, and this radius is around same to the radius of the buffer, which is around 50. So this 50 and this radius will be also 50. So you have to find out the area of this geometry.
Hundred into 1,000 meters.
Okay, and then take the pi value is 3.14. So the correct answer is 107,850 square meter. How? Like this is 1 kilometer. Okay, so which is around 1,000. So this is 1,000 and this 50 and this 50. The 50 is a the area of buffer of 50 meter. Okay, so 1,000 into 50 plus 50, which will become 100. So which will become 1 lakh, and then 10000. Okay, so this is the area of this rectangle, plus we have to add the area of this circle. So two semicircles are there. So area of circle we will add, so which will become pi r square. So pi will be 3.14 and r is 50. So which will become 7850. 7850. So 7850 plus 1000. So that will become 107850, and that unit will be in meter square because everything is in meter. Now in question they have asked us the area in square meter only, so the answer will be same only, 107850. But see the what units they have asked the question. If they have asked in kilometer square, then they have asked just write till one decimal place only, then your answer will be 0.1 because you have to divide this by 10 to the power 6, and you will do that, then you will get 0.10785. So if one decimal place you are doing, then it will become around 0.1 kilometer square. They may ask you area in hectares also, so you should know all the unit conversion from meter to square meter to square kilometer to hectare. Next question is, the spheroid, like choose the correct statement from the given four option. The spheroid is a mathematical surface of the earth. The geoid is an equipotential reference surface of the earth. True shape of the earth is perfect spheroid, and the WGS 84 datum varies from country to country.
A and B are correct.
Yes, so spheroid is mathematical surface and geoid is a equipotential surface. Datum is same for all the countries, because if we change the datum, then there is no, because datum is providing the reference. So that reference should be same for all the countries. And true shape of the earth is perfect spheroid. No, that is oblated from the like poles. The next question is from like definitions of latitude and longitude. So which of the following is the correct statement or statements? Latitude of a place varies from 0 degree to 90 degree north or south, and longitude varies from 0 degree to 180 degree east or west of the Greenwich meridian. Latitude of a place varies from 0 degree to 180 degree east or west Greenwich meridian, and longitude varies from 0 to 90 degree north or south. Longitude of a point is an angle between Greenwich meridian and the meridian passing through the point, and latitude and longitude of a place are subjected to change with time.
A and C are correct.
Yes. So latitude is from 0 to 90 degree north, 0 to 90 degree south. Longitude is 0 to 180 degree east and 0 to 180 degree west. And when we say longitude, then it is a horizontal angle which is it making between the Greenwich meridian and the meridian that passing through that point. So that is a horizontal angle which we can specify using the longitude. So option A and C both are correct. A map projection is a systematic representation of latitude and longitude lines on a plane map, a representation of 3D shape of Earth on 2D plane, dependent on the location of area on the Earth, and required for taking theodolite observation of horizontal angles.
D.
So yeah, option C here, A, B and C both are correct. Why? Because systematic representation of latitude longitude, which is always in 3D. So latitude longitude lines, because that is the 3D lines, and we are representing on a plane of paper. So option A is correct because of that reason. Option B is by default true because it's a representation of 3D object into 2D plane. Option C, dependent on the location of area of on a Earth. So yeah, that is also true because when we project a three-dimensional object like the globe, we have to see which part we are showing, because if we show just like this, then the top portion will be like stretched out, or some, if we are not doing it for top, then some other part will be stretched out. So we have to try to preserve area, direction, shape, all those things. So that's why what location we are talking about, and because based on the various locations we have many projection systems, and that's why this is also dependent on the location of Earth. So the next question is, what are the Manhattan and Pythagorean distance between the point A and point B? So between point A and C, the distance is 4 meter, and between B and C, the distance is also 4 meters. So which means that each block is 1 by 1 meter. So you have to see what is the distance between A and B, Manhattan distance and Pythagorean distance. So this is useful when we do the network analysis. How do you calculate the distance? Manhattan distance is the distance without going into diagonal. You just have to go street by street like this, up and down, up and down. Whereas Euclidean distance means the shortest distance, which is directly line joining these 2 points. So can anyone calculate the Manhattan distance first? How? So we'll go from this to this. So 1, 2, 3, 4, 5, 6, 7, and 8. So Manhattan distance between A and B should be 8. Similarly, if we go from here to here, A to C and C to B, then also 4 plus 4, it will become 8. Now if you take Euclidean distance, then this is 4, this is 4. So this will become 2 root 4, 4 root 2. So which will become around 5.7. Next question is, which vector data analysis tool combines geometry and attribute from different layers? Overlay, map manipulation, buffer, or Cartesian distance measurement?
Overlay.
Yes. The next question is, the analyst computes the average of two input raster layers to generate a new raster layer with the same size as the input raster layer. What type of raster data operation is performed? So this we have learned when we have learned about the interpolation. What is local, neighborhood, global operations, zonal operations. So this here they are specifying the size of both rasters are same. It means it is within that particular area only. And it's why that is known as a local operations. If it is outside the region, then it is known as a global operation. Zonal operation is when we are doing a moving window, that we are doing a range like moving mean or moving sum, or like this 3 by 3 window will move over the entire image, then it is known as a zonal operation. Or neighborhood means we will take the nearest neighbor data from the given window. Now next question is, match the following errors in spatial data digitization with their discrepancies. So missed located entries, missing labels, artifacts of digitization, duplicate labels, and then on column 2 we have point line and boundary segments digitized twice, point line or boundary segments digitized in the wrong place, undershoot, overshoot, and wrongly placed nodes. Yeah, which option should be correct? I think this you should be able to answer. So you can start with point S. So what should be the proper answer for S? Duplicate labels. Why do
Option
we
C.
need option C? No. You see the option like S, duplicate labels. So when do we have duplicate labels in QGIS? Because of what reason?
Option A.
Okay, anything else? Anyone? Okay, so let's see. So option A is right. So why? So the first one is mislocated entries. So mislocated entry means it's regarding the location. Okay, so it's obvious that it said wrong located or mislocated entry. It's related to location. So first is point line boundary segment digitized twice. So if it is being digitized twice, it has no point with mislocation. So one should not be the answer. And all other options are having two. So two is the right one. Second one is missing labels. Okay, we are not able to put the labels. So it means what? That we have undefined polygons. Means we forgot to give the label, and because of that, what will happen? That polygons are unidentified. We cannot give what is the name of that polygon, what is the name of that village which we have created, what is the name of that area that we have created, what is the name of that zone which that we have created. So Q will be 4. Then artifacts of digitization. Artifacts means what? Either undershoot, if it is supposed to go till that line, but it ended before it, that is undershoot. If it is ended over, then it's overshoot, or else it is just connected with the wrong dot. So that will create the artifact such as dangle also. So that is R will go to 3. Then duplicate labels. So duplicate labels means what? Like two or more identification labels for the same polygon. Now there is no unique ID which has been associated with the polygons, and that's why it's known as duplicate labels. And then last one was the duplicate entries. So duplicate entry means same two type of entries. So same thing digitized twice. So that is point number 1. So correct answer is option number A. So you should look into this definition: silver polygon, overshoot, undershoot, dangle, missing. These things we have discussed. It's there in PPT also. And this is very important discussion. Now tolerance used in GIS data editing are snap tolerance, width tolerance, grain tolerance, and polygon tolerance. So option number snap, width, and grain tolerance. Polygon is not there. So snap is the distance within which vertices or endpoints are automatically snapped together. Width is the tolerance distance between the vertices, removes the unnecessary points. Grain is minimum spacing between the input vertices while digitizing. Okay, so the next question is IDW interpolation at point 0. The table provides XY coordinates of the point measured in the row and column of a raster with a cell size of 1 meter and their known values. Using the inverse distance weight interpolation method and Euclidean distance, the interpolated value at point 0 is, so point 0 is 69,67, not here. Okay, so please keep that in mind. You should always look into those things. So now what is IDW formula is? Anyone knows what is IDW interpolation? Okay, anyone knows? So IDW is like you have to calculate distance and then you give the weight. So it will be like values plus divided by value divided by the weight, like this. So this is the formula of IDW interpolation. So value is equal to summation of Z value divided by its weight, 1 divided by its weight. So Z means value here. So value is 27, 10 and 30. Okay, so 27. Now 27 is point number 1. So 27 So basically the value divided by distance. So first one is 27 divided by, you have to find the distance between point 0 and point 1. So you will calculate x minus x1 square plus y minus y1 square under root. So here from 76 minus 67, you will get 9. So distance between point 0 and point 1 is 9 unit. Okay. So 27 by 9 plus 10 by, so the x difference is 10 and y difference is 0. So it's a 10. So then 10 divided by 10. Okay, and then for point number 3, the value is 13 and the distance will be 74 minus 69 whole square plus 79 minus 67 whole square under root that. So that distance will be 13. So 13 by 13. Okay. So for first one, it's like 27 by 9. Second one, 10 by 10, and then 13 by 13. So 1, 1, and then you have 3. So 3, 4, 5. So 5 divided by 1 upon 10, 9 square, 1 upon 10 square, 1 upon 10 square. Are you getting what I'm saying? Or any doubt? Let me write it here only. So for the first one, you have 27, and the distance between this point and this point is around 67 minus 76, which is 9. So 9, then you have this point, okay, which is 10 points away. So for that, 10 divided by 10, 10 divided by 10, and for the third one, it is distance is 13. So 13 divided by 13. And how I calculated this distance is, you just have to use standard distance formula, which is under root of x minus x1 square, x1 minus x2 square. Sorry for my writing because I'm writing through mouse pad, so I'm not able to write it properly. And this will become y1 minus y2. Okay, so using this, you can find out the distance between 2 points, and then after you can use this. So IDW means this divided by 1 upon distance square, because 9 square plus 1 upon 10 square plus 1 upon 13 square. And doing this, you will get the value, which is x. So this will become, on top it will become 5, and here if you do 1 by 81 plus 1 by 100 plus 1 by 169, and that will be multiplied by 5. So you will get around 0. Around like this. Okay, okay. So here also we have to do a square. Okay, I forgot. Here also we have to do square. Yeah, it's a square. P means we are using second order polynomial. Yeah, so yeah, you use this formula. Okay, so 9 into 9, 20, like 81. So you do this and you will get around 17.24 or 17.25. 86. The next question is, which of the following statement is true for the World Geodetic System WGS 1984? WGS ellipsoid best fits the shape of the Earth, including the topography. The WGS 84 ellipsoid and the Geometric Reference System 1980 ellipsoid are one and the same. The WGS ellipsoid is not geometric ellipsoid. WGS ellipsoid can be used to determine geoid. So it can be used to calculate geoid. Other three are wrong. Which of the following statement is correct? Mean sea level is defined as the long-term mean of the tide gauge measurement at a location. Mean sea level is the same as the mean tide level. Mean sea level is defined as the monthly mean of the tide gauge measurements, or mean sea level is an approximation of geoid.
A and D.
Yes, A is right, D is right. Next question is, which like the table below is an attribute table about the employee records. Which attribute can be used as a primary key? So employee name, employee ID.
Option B.
Option number
B. Employee ID, because
fine.
it's unique.
Next one is the first value in the output of SQL query when run on a table having a name table 1, which is this one, is, so we are running this query. Select last name from table 1. So select last name where state is equal to India. State is equal to India and ordered by first name. Then we have to order the name by its first name. So once we run this query, what should be the answer?
Option D.
Douglas.
Okay. So the query filter records where the state is India. So first we'll take this and then sorts the alphabets by first name. First name means we have to do A to D. So here if we do is like then this so
Douglas Ramirez.
yeah, so India, okay, because we have to select the last name, not the first name. Okay, so please be careful. We have to select last name, not the first name. So India is means this three only. Then first name, and that will define like order by it's a order. So this D, E, and P, and then we have to select the last name. So the answer will be Ramirez. So this kind of question you also are like ask like expect not in this NPTEL exam, but I think in your GATE exam here also you may expect some this kind of thing as well.
But I have a doubt in the
Yes,
previous
yes,
question.
yes,
We are ordering by first name, correct?
yes,
So first name's order is E. Oh yeah, okay, fine. Understood.
yeah. Next is consider the three input rasters given images given below. A geospatial analyst decided to use the overlay operation to generate a new raster showing in average values. The value of pixel cell PQR will be output raster will be. So we want to do overlay operation to find out the average value. So what will be value of PQR? This is very simple. Chalo quickly. So you have to take mean value of P, Q, and R.
Option A.
Yes, so 5 plus 1 plus 3, which is 9. 9 divided by 3 which I will do. So you will get 3 as a P. Then for Q, 2 plus 3 plus 4. Then also you will get 3. And for R, 3 plus 2 plus 1. So 6 divided by 3, which will give you 2. So option number A is correct. So basically sum of this divided by 3, this divided by 3, this divided by 3. Next question is, in a geographic information system database, a stream is represented by a line and houses are represented by polygon. The pollution in stream is affecting houses within a distance of 500 meter on both sides. Which vector data analysis operation should be performed to identify house affected by the pollution in a stream?
Option A, sir.
Yes, first we have to take a buffer of river and then overlay it with the building. So buffer and overlay. Next question is Voronoi polygon correct state. So basically, which of the following statement is or are correct for the in the context of Voronoi polygon? So Voronoi polygon may contain more than one point, especially when the density of points is higher. The center of a Voronoi polygon is circumcenter of a denominator triangle. Each intersection of Voronoi edges belongs to. So I think this we have touched upon when we have discussed the teen network, and correct option here are the each intersection of this edges belong to the at least 3 Voronoi polygons because it's connected by triangle faces, and Voronoi polygon denominator triangles are the geometric dual of each other. So I mean this is the extended version of what you learned in the teen. So then next question is, which of the following map projection is not conformal? Transverse Mercator, stereographic, Lambert conformal conic, or sinusoidal? So this also I think you have to recall the things which you have learned on formal projections. So the answer here is sinusoidal, that is not a conformal one. Transverse Mercator is a conformal used in UTM. The stereographic is also conformal used for polar region. Lambert conformal conic is also conformal. So this is not like this kind of question, you do not expect this difficulty level in NPTEL exam, but yeah, this if you are appearing for GATE, you might expect where you have to do little bit extra what you have learned. So extra material you have to explore. Which of the following technique is not used to atmospherically correct the satellite image? Image normalization using histogram adjustment, radiative transfer model, image to image registration, image normalization using regression.
Option C.
Yes, so image to image registration is used for which application?
For georeferencing.
Yes, exactly. That is used for georeferencing and not for the atmospheric corrections. Okay, so the next question is, which of the following is not a geodetic reference frame? So EGM 96, WGS 84, ITRF, and NAD. So WGS, ITRF, and NAD all are like horizontal coordinate system. As the EGM is for vertical, not for the. It's a gravitational model for useful for geoid and not for the coordinate system. Then UTM is a conical projection, azimuthal projection, polyconic projection, or cylindrical projection.
Option D, sir.
Yes, it's a cylindrical projection. Identify the category of the map scale given below. So we have 4 maps P, Q, R, and S, and their scales are given here. So you have to tell me that which scale is large and which scale is small. So remember the definition of scale. Distance on map divided by distance on ground.
Option yes, sir.
Option A. Okay. Anyone else? So from the option itself, it is very clear that either option should be correct answer should be A or B, because C and D are directly, if this is similar, then this should not be like P and Q should come together and S mostly come together. So most of the time this option is like mostly from A and B only. So now you can see here for A and B, like distance on map is 1, which is representing 1000 meter on ground, actual ground. So here the scale is large, where here the scale is small. Small scale means very large distance we are representing by the very small amount. So the scale is small, not the large, because we see 1 divided by value of 1 divided by x, not the value of x. Okay, we do not see the after column value. We see 1 divided by x total value. So if denominator is large, it will become, overall value will become less. And if the denominator is less, it will become big. So the P and Q are large, whereas R and S is small comparatively. And yeah, the question can also come in such a way that which map has highest details, which map is having highest partial resolution, which of the following map is having least detail. Okay, now they can give us that all maps has area of, they have 625 by 625 pixels. Then which map will have highest area? Okay, so that kind of questions can be generated from this question, that by comparing scales, you have to answer. Any doubt? Okay. So another question, A represents all the road, street light, tree and building of a campus of 5 kilometers square, whereas B map represents the forest agriculture area of a district, which is 1 lakh kilometers square. Considering the physical size of both the map same, which of the following statement is or are correct? Now scale is different, but both represent same area. So physical size, like considering the physical size of both the maps. Physical size means the distance which it represents on the actual ground. So the first one is 5 kilometers square and the B is 1 lakh kilometers square. So obviously B is a larger map, like bigger one, and it is useful for a coastal details because it is a relatively, like for A, the scale is high because we can see a lot of detail into it. Whereas in B, the scale is small and we can see the coarser details into it. Okay. So here, please keep in mind, like when you write 1 raised to something, the first one is a distance on map and the second one is a distance on actual ground. If the distance on actual ground is very big, then you cannot see more details on a actual map because you are representing a large dimension into a smaller map. So that you will lose the control on the detailing part and the scale will become small. Whereas if it is smaller value, then the scale will become large. So please keep this thing in mind. Next question is, which of the following is or are preserved in the Mercator projection? So shape, true direction, equal area and shape along the standard panel. So the answer here is shape and true direction. So both things are being preserved in the Mercator projection. The next one is, which of the following statement is not correct in the context of GIS? A raster data model makes a use of grid of cells that are organized into row and column. Vector data represents partial features on Earth's surface in terms of point, line, and polygon. Resampling is applied after georeferencing of vector data set. Topology is used in vector data model to ensure the spatial data integrity. So which one is correct here? Question number 49. Anyone? So first two are obviously correct because raster data we use grid, vector data we use point, line, polygon. So option A and B are correct. Resampling is applied after georeferencing of vector data. So if that is wrong, resampling we do for raster data set. So option number C is not correct. And that is the answer for this question. The next question is, which of the following statement is not correct in the context of shapefile? So shapefile, it is an example of georelation data model. It is a topological data model. So it treats the points as a pair of coordinates x and y. In this, polygon can have duplicate arcs for shared boundaries. So option A, C, and D, all three are correct, whereas B is wrong. It's not a topological model. Their shapefiles are a non-topological model. They do not share boundary information. Okay, they like it will be repeated if you say, but then you can convert that into topological once using some kind of model. You can convert your vector data into topology. Next, the square digital image of 128 by 128 pixel requires 65,530 bits of storage. What is the number of gray levels? So here that is a reverse question. The number of bits are given. So you have 65,536 divided by 128 by 128. So you will get number of bits. So what should be your answer? So 65,536 divided by 128 into 128.
Option B, sir.
So you will get 4. Okay, again the same question. This thing is given and you have to use bilinear interpolation and you have to find out the value at x. So this kind of questions we have just solved in the previously. So I will not cover this. So you find how much distance is changing and according to that how much value is changing. So if you go from here to here, it is decreasing. Similarly, here to here, it is decreasing. You will find the value at this and this location. And then from here to here. So this is the formula which you can use, but better thing is you just do by yourself using the normal common sense rather than using some formulas. So find the best match between column 1 and column 2. So like this is the kind of spatial operator we use. So this is within the border, within the tangent, within the strict. So this is within the tangent, like tangent. It's a tangent at this location. This is at within a border. So Q will be 1 and R will be 3 within the strict. So inside it. For three circular regions, P, Q, and R, select the Boolean operator which returns the shaded area. If we need this as an answer, what should be the GIS operation which we have to perform? So, like if we say this one, then it's a P and Q and R. But for this one, not P or Q. So P and Q, not P or Q. Okay, P or Q means it's a fully. And if you remove this, then this will be remaining. So the answer is A. But if we see option number B, P and Q. So P and Q. So that will be this much. Okay, and not P and Q. So you will get this also, and this also. P or Q or R. So that will be entire thing. And not means you will get nothing. P or Q. So P or Q means this two. And then and R, which is common with R. So this will give this particular thing. And if you use not operator after that, you will get this black as well as this black portion, excluding this kind of thing. So you should know how this operator works, and or not. Okay, I think our time is already up, but I think I have some more questions. I will upload this file into your NPTEL repo, so you can go through it. So there are further questions which are also there, but yeah, because of the time constraint, I think I will not go into this. So this all questions are being asked in the GATE examination. Uh, okay, so you can, I mean, I will upload this thing and you just go it. Like most of the questions now are like theoretical question only. Whatever the numerical and logical questions were there that we have already covered. So you can go through this, and if you have any doubt, you can mail me. I will be happy to answer your mails. I think with this, what we can do is I will just have a quick. So yeah, let's just talk now. I think it's if you can turn on your just video, because I think we are just closing this session, so it would be great if you can switch on your videos. So may I request everyone, like, can you please keep your video on for last 2-3 minutes if possible? Okay, yeah. So that I can see you, like, to whom I have teached during this uh, course. So thank you everyone for joining all the doubt sessions sincerely, and few of you have done very good job and responded very well to entire doubt session class. So I mean, thank you very much for joining, and hope you learned, and I was able to cover most of the part. If your questions, your doubts, and I was trying to my best to put the question answers from the week which you have learned. So I hope you enjoyed this course and you will learn something from it. So, and you will apply the same thing to your discipline or work where you are working in. So yeah, thank you everyone for joining. And if you have any problem in this course before your exams, please reach me out through my mail ID or the NPTEL chat box. And once again, thank you for joining. And if you further also, if you are any, like, I am doing up my PhD at IIT Gandhinagar. If you are coming to Gujarat, IIT Gandhinagar, please do visit me. You are welcome here. So thank you everyone for joining this course. Thank you. If you want to say anything, you are welcome to say a few words.
Thank you, sir.
Okay, so thank you everyone. So if there is no,
Thank you for your wonderful sessions.
thank you, sir.
It was really an enjoyable journey.
Thank
Thank you
you.
very much.
Okay, thank you everyone. Okay.
Thank you, sir. You have really enlightened us. Thank you so much for your for sharing all this knowledge.
Thank you, you guys, for joining and making it. Because most of the time it's not like people do not respond, but yeah, 3-4 people, like, they are responding every time when I ask question. And thank you so much for enthusiasm. I really enjoyed teaching along with you. So thank you, everyone. Great to see you. Have a best of luck for your exams. Bye bye.
Good night.
Good night.
Thank you.